So let's change the operation back to pull. And let's press play just to see what's happening. So notice how just by adding the temperature, this density is rising. And this is due to a phenomenon called buoyancy. And you can take a look at this property if you scroll up here on the Solving tab, under the Simulation tab. Again, if you scroll down, you will notice there's this buoyancy scale. So currently the scale is quite large. So if we bring down this value, the ink should rise much less. So let's take a look. So notice how the velocity is initially pushing this density downward, but then the buoyancy is bringing it back up. And this is very important because if you remember, this is exactly what we noticed on the reference. First of all, the ink is being pulled downward with the pressure of the syringe or wherever is pushing the liquid, and then the buoyancy of the water is bringing this ink back up. So now all we have to do is to balance the incoming velocity with the buoyancy scale within the simulation. And the final value you use here will depend not only on the reference that you're looking at, but also on the motion you're looking for. For example, to create this cloudy and floaty look, I had to balance these two values almost equally. So let's try with point 1. Let's go back to frame 1, press play. And notice how we have a little bit of this density rising, but most of it is moving downwards, which is actually what I'm looking for. So at this point, I think we can create a flipbook just to see the current result and be able to tweak from there. So I'm going to move a bit backward. I'm going to create a flipbook, and I will be back once the flipbook is ready.